Hello, Rob and Beth here, and we're on to another session with chemistry, atoms, elements and compounds. Subgroup here we're looking at as far as the syllabus is concerned, atomic structure and periodic table part 1. So here's the learning outcomes that we'll be concentrating in this part 1 series. Determine the electronic configuration of elements and their ions with proton number 1 to 20. And as an example there, 283. And in part 2, we'll state that the group 7 noble gases have a full outer shell. The number of outer shell electrons equal to the group number in groups 1 to 7. And the 6th part C, the number of occupied electron cells is equal to the period number. Okay, like all my lessons, we're going through a certain format. I'd like to pose some questions. Some of you may be able to answer this. If you can, great. If not, listen and learn the best we can. Do you know the first 20 elements? Maybe you do, maybe you don't. Can you name any 5 elements, as a matter of fact? Any at all? Where can you find elements? Where and how many electrons are found in an element? Can you answer this question? Maybe some of you can. Do you know how elements are arranged in the periodic table and why? There's a bit of history for those people who like to determine where and how the periodic table came about. Rules for the first 20 elements in terms of the electronic configuration and their proton number are as follows. So in the first shell, the rules we have to the quantum theory, the first shell has a maximum of 2 electrons. So I'm just going to draw in here 2 electrons always. The second shell can hold a maximum of 8 electrons. Third shell can hold a maximum of 18, but for this course we'll be only going up to 8 electrons in terms of the first 20. And then the next shell it'll be 32. But we won't need to use 18 or 32 because we're only looking at the first 20 elements. But as we go into higher order chemistry in IB, ion levels, you'll be expected to know these numbers of electrons. Okay, rules for writing chemical symbols. In general, the first letter of the chemical name is the capitalized, and then the second letter is lowercase. So if we have a look at the first example here, where the dot represents an electron, we've got hydrogen, and you can see we've just written the first letter from that, H, and then helium, you can see we've written the first letter capitalized and the second letter lowercase. That's not always, in general, what the case is. We'll have a look at a few exceptions in the periodic table. Here we go. Here's the electronic configuration for hydrogen. You can see here it's got 1 proton in the nucleus here, 1 proton, and you can see these little dots of 1 electron. So that's in the first shell here, and that's the first shell. We go to helium. You can see we increase by 1 electron in the outer shell. So now we've got 2 electrons, and that's equal to 2 protons, as in the increase of electrons. So helium has 2 electrons in the outer shell, that's full. You can see it's got 2 protons and 2 neutrons there in the center. Okay, so we're looking at the examples of a few other elements in the electronic configuration. We have carbon here. We can see we've taken out the element. Remember that bottom number stands for the proton number. So I'll just say Pn, and the top number stands for the atomic mass, or we know as the nucleon number. So I'm going to say nucleon number, just a dash dash. So we can see there it's got 6, so 6 protons represent 6 electrons. According to our rules of electronic configuration, the first 2 electrons in the first shell, so that's the first shell here, 1, 2, so that's the first shell here, maximum electrons is 2, and then the third, 4th, 5th, and 6th start filling up the second shell. So 2 plus 4 gives us our total number of electrons. Fluorine does the same thing, naming system, first letter of the capital. Fluorine, we take that as the chemical symbol F, has 9 electrons, And the first order shell filling is the first shell gets its 2 electrons maximum, and then we've got the 3rd, 4th, 5th, 6th, 7th, 8th, 9th electron. So we've got the shell electron here is 2,7 as a shorthand written electronic configuration. We go back to carbon, it's 2,4. You can see it's filled up. 2, and then the 3rd, 4th, 5th, 6th electrons are in the second shell. Same thing for neon. We've got 2,8, and we've got the electronic configuration drawn here. You can see there's 10 electrons. Add 2 plus 8, you should get that number there. And the same for phosphorus. Here you've got 285, and that'll be atomic number 15. Hopefully you're getting this. We'll go a little bit more. Here's a few more examples of the first 20 elements electronic configuration. We have argon here. Again, going through the process, argon is 18 as the proton number, so there's 18 proton number. That means it's also equal to 18 electrons. And then we go through the rule. In the first shell, we've got 1, 2 maximum. Second shell, we've got 3, 4, 5, 6, 7, 8, 9, 10. So we've got 8 electrons there. And then we get the 11th electron has to go to the third shell here, which is this one here. So we've got 11, 12, 13, 14, 15, 16, 17, 18th electron. Hence the 2, 8, 8 configuration. You'll notice argon is a noble gas. We'll learn more about that later in next part 2. Okay, the next one here, calcium 20, electronic configuration 2882. Followed the rules. Hopefully that's explanatory. Remember, we can also give this as a diagram, and then you might be asked to work out what element it is just from the diagrams and electronic configurations. So make sure you can go forward and back. Remember, this is just a shorthand electronic configuration here. It can be written like that, 2882, or you can draw it up in terms of the shells. Okay, things to know about learning the first 20 elements. I would like to be able to learn the first 20 elements from hydrogen to calcium as per the syllabus in the chemistry syllabus of IGCSE. Okay, I get my students to learn by chunking here. So if I just underline here, chunking, whereby you learn a small number of elemental names and symbols using a mnemonic. Now I'm just going to go through what a mnemonic is. Here's a nice simple way. Make sure you use a sentence that you know how to use and you can learn best. Make sure you keep it appropriate, yeah, but whatever works for you. Okay, I use for the first 5 elements, I use this sentence called Happy Helen likes being beautiful. As you can see from the letters highlighted here, H for happy, HE for Helen, LI for likes, BE for being, and B for beautiful. These also correspond to the first 5 elements. H for hydrogen, HE for helium, Li for lithium, Be for beryllium, and B for boron. They're also in proton number order. So that's a good way to learn your first 20 elements. You'll be given a periodic table, obviously, in your exam, but it helps, especially the time aspect, management of your time, that you know your first 20 elements. You can then use it if your time isn't upon you and hasn't been used up. Use your periodic table to double check yourself. Would be a good way. Okay, here's the next bit that you want to learn. Continue to learn the next 5 elements using the same technique with the mnemonic. The previous slide for the elements in proton number form. So you can go from carbon number 6 then to element number 10, and then use a silly sentence or a sentence that makes sense to you, whatever works for you. Then you continue on to the last element, calcium, up to 20. So spend some time doing that. You'll benefit a lot from knowing those first 20 elements, and when we go a little bit further into part 2, the position and location of those elements will help you with its period and other aspects. Now, as always, testing your knowledge. Hopefully you've been going through that. Here's a quick 3. See what you know from this first learning outcome. Name the element given it has a proton number 4. Remember to stop and pause, give yourself time, write your answer, go through the process. It's good for your thinking. Number 2, given the element is called sodium, what's its chemical symbol? So have a think about it, write it down. Doesn't matter if you get it wrong, as long as you're going through the process. The last question here, given the electronic configuration of the element drawn below, what's its element's name, chemical symbol, and proton number? So sometimes examiners like to give it to you in terms of a diagram. So you need to know, what the hell is that element? Okay, let's go to the answers. Hopefully you've been pausing, having a go. Let's go to the quick 3 answers. Okay, here are the answers. Let's go through them. So number 1, it said here, name the element given its proton number of 4. If you're learning it using the mnemonic, it is beryllium. Beryllium, proton number 4, chemical symbol Be. Question 2, given the element is called sodium, what's its chemical symbol? And the symbol is Na, capital N little a, Latin name. Now, we didn't use sodium as in the word because S is already taken with sulfur. So we revert back to when we used to all speak Latin across Europe, and it's called natrium. And natrium's first letter from the naming process is N, but that's been used for nitrogen. So then we had to go to the second letter, nitrogen. So then that's why it's called Na. So then we don't get a mix-up between nitrogen and sodium. So there's actual separation in terms of chemical symbols. All right, next part of the question, number 3. Sorry for writing all over that. Given electronic structure below, it's called argon. Chemical symbol Ar and proton number. So the simple way you can work out this, just count all the elements, all the electrons here. 1, 2, 3, 4, and you'll find there's 18 is the number of electrons, and that equals to the proton number, 18 protons. Then from that, if you know what the 18th one is, then you can figure out it's argon.